welcome. A long time ago, there was this guy on SportsCenter on ESPN that every time the show started, he would say, welcome. It's like scary. I don't know why he did it. It had nothing to do with sports. And this has nothing to do with math whatsoever. Just thought it was funny. Okay, so interim review, part one, part the first. We've got three functions on the side here. There's a linear function, right? Straight line. Well, not like that. Straight line. We've got a quadratic, and we've got an exponential. Right? Right, like that? Okay. Or like this, right, depending on how it looks. I want you to come up with the characteristics of these functions. Where did my thing go? Where did my cap go? Oh, here it is. I want you to come up with the characteristics of these functions, then we'll graph them, and then I want you to try to make some conjectures or some other things, language arts term, about these three things, like which ones will always have something, which ones will not. Like you always know an asymptote will be part of an exponential, never will be quadratic or linear. So these are the characteristics I want for all three. So let's go with domain, let's go with range, let's go with the Y-intercept, let's go with the X-intercept, in behavior, increase and decrease, asymptote line, what else? Now I'm missing a whole lot probably. Odd or even I don't really care too much about because that's something that's not really all important. Positive, negative, it's not really something that I really want to do. Yeah, let's just start with that for now. Oh, let's go with this. Min-max, because min-max is important. All right, so go ahead and try those for now. If I'm missing any ones, just go ahead and do it. Pause me, because I'm going to go right ahead and solve these three or give you the answers for these three after I take a bite of my oatmeal. Maple brown sugar. It's delicious. You can see me eating from the side. It's weird. Okay. I'm stupid. Okay. Hopefully you pause me. Got yourself a bowl of oatmeal or something. All right. Let's go with the linear one. So let's go with y equals 5x plus 3. I'll put that on the board so you can see it as we go along. You should already have your answers, however. Okay. So there's the function y equals, or f of x equals 5x plus 3. The domain, it's all real numbers. Or better known as negative infinity to positive infinity. Okay? The range of this function, again, all real numbers, or better known as negative infinity to positive infinity. Can you give me an instance where it isn't domain or range positive infinity to negative infinity? Or negative infinity to positive infinity? Well, good. You're right. So if it is a straight up and down line, so for instance, x equals 10. The range is all real numbers for that, but the domain is only 10. Because it doesn't touch any other x value but 10. Now, the opposite is true for a zero slope line. So let's say we have the line like this, y equals 5. The domain is all real numbers, but the range is only 5, because it doesn't touch any other y values. Okay, good. Y-intercept. Well, the y-intercept is easy, it's 3, because it tells us what it is on the side here. Now the x-intercept we have to do a little bit of work for. So the x-intercept is when y equals 0. So for this, we plug in 0 for y, and we solve for x. So I'm going to subtract 3 on both sides, and we're getting into way end behavior. So negative 3 is going to equal 5 times x, divide by 5 on both sides. And my answer, my x-intercept, is negative 3 over 5, right? Or negative 0.6. That seems about right. Okay, so we'll do negative 3 over 5. That's fine. Okay. End behavior. And yes, you can do end behavior for these. As x approaches negative infinity, f of x approaches positive infinity. No, I lied. It's negative infinity. Sorry. So, I was getting confused. As x approaches negative infinity, f of x approaches negative infinity as well. And the opposite is completely true. So, as x approaches positive infinity, f of x also approaches positive infinity. Trying to go fast. Okay. Increase and decrease. Well, this function's always increasing. It's never decreasing. So it's increasing on the x-axis from negative infinity to positive infinity, or it's increasing on all real numbers. Asymptote, there's no such thing for a linear. And min-max, there is no such thing here because it doesn't end anywhere. Like if I made this a line segment and I stopped it like right there, and it didn't go any further, or I stopped it like right here and didn't go any further, then it would have a min and a max. But because I didn't do that, and I will never do that, it doesn't. So that's what's going on for there. Okay. I'm just going to erase this side of it because I want to compare at least another function. So let's compare this with the quadratic. X minus 4 squared minus 4. Okay, I'll put that on the board. Okay, that's what it looks like. You don't have to sketch it. I wasn't really looking for that. But let's go ahead and domain. So the domain is all reals, all real numbers. We'll just go all reals because that's cooler, right? Also known as negative infinity to positive infinity, okay? Because it's going forever on either side of the x-axis. The range, now this is a little different. The range is from -4, right? Because this is the lowest y value this function touches. So it's -4, and I said a key word there. I'm awesome. It said touches, which means it's a bracket, right? Because it actually does touch -4, and it goes to positive infinity because it goes up forever. Okay. The y-intercept, okay, it appears to be up here, but we can do this by, because I wrote all over this, we can do this by plugging in 0 for x and solving for y. So I'm going to do that quickly. So -4 squared is 16, minus 4 is 12. So you should have had 12 for the y-intercept, and that looks about right, because 12 is about there. Okay. The x-intercept, because the quadratic it touches twice. Well, you can see it's 2 and it's 6. Okay. Now, if you didn't know for sure, you would put in 0 for y and solve for x, and then you would have the square root thing that we've done before. But you may just be able to look at it, which in this case I can. So 2 and 6 is my x-intercepts, which are also called what? Solutions, answers, roots, and zeros. Okay, so you need to make sure you have all of those in mind. When I ask for any of those things, I'm asking for the x-intercepts. Okay, increase, decrease. Okay, this one's harder. It's doing both. So it's decreasing, right? It's decreasing. It begins its decrease at negative infinity. So negative infinity is where it begins its decrease, and it stops decreasing here, right? Because this is the vertex of this function, at 4. Okay. And we always have to use parentheses with that because it's not technically doing anything there. And it's increasing just the opposite, from 4 to positive infinity. It's term 4. Okay. Remember, increase and decrease is kind of like domain. Where on the x-axis is it going down? Where on the x-axis is it going up? The asymptote line. There is no asymptote line. It's quadratic. And min-max. It does have a min and max. Remember that min and max is also called the vertex. It's specific to quadratics. And the min is here. It's the minimum value of that quadratic. And that value is 4 comma -4. Or f of 4 equals -4. Okay? Good. So let's do a little comparing right now. They both have domains. They both have ranges. But ranges are different for quadratics because it's a little different. Linear functions have all real numbers as their domain and all real numbers as their range, unless it's horizontal or straight vertical. They both have y-intercepts. They both have x-intercepts. Now, the quadratic may not have an x-intercept if it's above or hovering above or below the x-axis. End behavior, they both have end behaviors, and they're typically the same. We didn't do end behavior for this one. End behavior, as x approaches, I'm not going to do it because it's going to take too long. As x approaches negative infinity, f of x approaches positive infinity. See, I'm looking at here like it's a mirror. And as x approaches positive infinity, f of x approaches positive infinity. Quadratics are always going to have the same end result. Whether they're both going up or both going down. Increase, decrease, different because quadratics have both directions. Again, no asymptote, and min-max is only specific to quadratics. Exponentials don't have a min or a max, okay, because they don't have an end point. Good. Let's finally do this last one here, this exponential, and then you can do some comparing on your own. Long video, I know. I'm awesome. Here is the exponential. 3 to the x power. Okay, then we'll go quick on this one. Domain, all real numbers. Negative infinity to positive infinity. It lives on the x-axis forever. Range, tricky. Okay, so the asymptote is here, right? Which means that this line will never touch the the x-axis, which means it will never touch 0. Okay, it's an asymptote. It will get infinitely close to 0, which it looks like it already does, but Desmos doesn't go that far. It's not as cool as me. or as intelligent. So it's 0 to positive infinity for the range. The y-intercept, all base exponential functions have a y-intercept of 1. X-intercept, there is no x-intercept because how can it if it doesn't even touch the x-axis? End behavior, okay, so I'll just write the one that is the most meaningful. As x approaches negative infinity, f of x approaches what? 0. Okay? It'll approach 0, but it'll never actually touch 0. Increase, decrease, it is always increasing. Even here, it's still increasing really, really small. Here, it gets way, way faster. So it's always increasing, on all real numbers. Okay, negative infinity to positive infinity. The asymptote line is y equals 0. And the min-max, there is no min-max. Okay? So, hopefully, that's what this unit is, really. We talked about this. 11-minute video. So make sure that you understand these three. Go back again and make sure that you have all of them. If I forgot one of these characteristics, sorry, don't hate me too much. All right, see you later.